Okay, guys, so today we're going to learn about Newton's second law of motion. So go ahead, Newton's second law of motion. So a second law of motion is also known as, aka, force and acceleration. So what I like about this one is this is something that you've basically known all of your life. They have just put it into a formula. So that formula, which is super important, is force equals mass times acceleration. So I'm going to put that here. Force equals mass times acceleration. We know that force, the unit of measurement for force is the Newton, so it's going to be Newton. For mass, it's going to be either grams or kilograms. And then for acceleration, it will always be meters per second squared, just like when we were doing acceleration, when we were doing speed, velocity, and acceleration. So the second law states that an unbalanced force which of course is always going to be F, acting on an object causes acceleration. And that makes sense. We know that if we apply a force to an object, whether it's a push or a pull, it's going to cause acceleration. Okay, we know that. And what does acceleration mean? Remember, that means change in motion. Change in motion. So it will cause a change in its motion, in the object's motion. How much acceleration? So how much acceleration, or how much it accelerates, depends on its mass. And again, that also makes sense. We've known that as a child, we can easily move a little toy car versus dad's car. Okay, we've known that if we apply a small force, let's say 10 newtons, that it's going to accelerate. This will move. But if we apply that same force, 10 newtons, to dad's car, it's not going to move because its mass is too big. No acceleration. It's not going to be able to do it. It's not going to do it. Done. Now again, Newton's law is all about using this formula. Force equals mass times acceleration. We say F equals ma. Now, there are some times where we are going to need to solve for force. There's others that we're going to need to solve for mass. And today we're going to solve for acceleration. So we're going to have to use this formula and put it into a triangle. So in order for this formula to be put into a triangle, everything to the right of this equal sign has to stay the same. Mass needs to be next to acceleration. And by looking over here, the only way that mass can be next to acceleration is if it is here. It's still mass is next to acceleration. If we put acceleration down up here, it's on top of it. So that's not going to work. So then we put force because we're missing our force. So force equals mass times acceleration. So I like to do this here. This is a little divide sign. Divide. And right here, it's a times sign because if things are side by side, we multiply those. So that gives us three different formulas. This one, original, force equals mass times acceleration. If we solve for acceleration, we cover up acceleration. So if we cover up acceleration over here, what's left is force on top of mass. So force divided by mass. Okay? Now, let me redo this over here. Now, if we have to solve for mass, I'm going to do this. We're looking for mass. We don't know it, so we put an X on it. We're solving for mass. Now we've got force and acceleration. Force is on top of acceleration, so that means force divided by acceleration. So always make sure that you use your triangle, because there will be times where you have to solve for force. If we're solving for force, you should have a unit of measurement of N. If we're solving for acceleration, you should have a unit of measurement of meters per second squared. And if we're solving for mass, it's going to be either kilograms or grams.